it records immediately. Nobody's excited about that, but I am. All right, so the first equation we're going to do is x to the third minus 2x squared minus 8x, and that's divided by negative 2x squared plus 4x. Okay, so what do we do first? You can find the y-intercept. So if I look at this, there's no number on the end of either of those. So what should I do? Plus 0, and 0 divided by 0 is nothing. Don't kill any baby Arctic foxes today. We just say none. Okay, what else can we do? Yeah, we can look to see if there's a horizontal. And what does this tell us? That there's no horizontal, there is an oblique. Okay? So that means we have to do what? Long division, our favorite, right? No? Favorite? No? So we've got x to the third minus 2x squared minus 8x is being divided by negative 2x squared plus 4x. Okay, so let me zoom in. All right, it's slanted. There we go. All right, so what do we do first? Negative 2x squared multiplied by what is x to the third? Negative 1/2 x. Okay, and now what do we do with that on the top? We multiply it by each of these, and we write it underneath. Sorry, I missed the little squared right here. That's my bad. Okay, so negative 1/2 x times negative 2x squared is positive 1 x to the third. Negative 1/2 x times positive 4 is going to be negative 2x squared. And then what do we do with that? Draw the line, change the signs. Those are 0. These are 0. So now, and you could even write 0x squared if you want, negative 2x squared multiplied by what becomes 0? 0. Okay, so our oblique asymptote is y equals negative 1/2 x, and you can put the plus 0 or not put the plus 0. You are equally accurate either way. So a slope of negative 1/2, a y-intercept of 0 is what we have. Do you guys want to draw this stuff as we go, or do you want to wait till the very end? As we go? Okay, so we can go ahead and draw that slant asymptote. We have a y-intercept of 0 and a slope of down 1, right 2. So on here, I've got y-intercept of 0, and then I'm going to go down 1, right 2, down 1, right 2. I know some of you guys are probably a fan of drawing really straight lines, so if that's you, I do have rulers in the back by where the markers and stuff are, and you're welcome to use those rulers, okay? So here's, I should be drawing a dotted line right now, and I'm just really committed to this, so I'm going to go back and erase a little bit and make it dotted, but there's my slant asymptote right there. It's supposed to be dotted since it's an asymptote. It's not really there. Look at that dotted line. Do you believe it, that I did it dotted to begin with? Oh, man. Okay. I like it when I laugh and nobody else does. That's not awkward at all. Okay, so we've done everything we can with the standard form of the equation. We have graphed our slant asymptote. What do we need to do now? We got to factor. So if I look at the top, what do you notice that we could do with the top? GCF of x, so that leaves x squared minus 2x minus 8. So to multiply to negative 8, but add to negative 2. Okay, so x minus 4, x plus 2, okay. On the bottom, what's our GCF? Negative 2 and an x. And then what would be left over? X minus 2. Okay. So what do you see? Any canceling? You can cancel out the plain x. Do you guys see that? Yeah. These. Yes. You can. Oh. If there's a plus there, you can't because you'll kill a cow. But these are all multiplied, and these are all multiplied, and that's why we can cancel. Yeah. Okay, so we're canceling that out. That means there's a hole, and what is the x-coordinate of the hole? 0. The x-coordinate of the hole is 0. So that means we're going to take all of our leftover stuff, the x minus 4, the x plus 2, the negative 2 in the front, the x minus 2. We're going to write all those leftovers down. And then we're going to take all those leftovers and plug a 0 in for the x. So I have negative 4 times positive 2 is negative 8. And I have negative 2 times negative 2 is 4, right? And negative 8 divided by 4 is negative 2. Okay? And so the point 0, negative 2 is a hole. It's not a real point on the curve. It's a point that's missing from the curve. Okay? Now, I have had students at the end of the unit, they have a random hole on their paper and the curve doesn't come anywhere close to it. That means you did something wrong. The hole has to be on the curve. It's a point missing on the curve. Does that make sense? So our curve has to have this point on it. Has to. If it doesn't, your curve is wrong. Something's wrong. Your hole is wrong. The curve is wrong. Something went wrong. All right. So the hole's done. What else can we find? We can find the vertical asymptote. So here there's 1 because we have 1 factor left over. So what is the vertical asymptote? 2. X equals 2. You know what? I should have just done all these in the colors. I didn't do that. So you can see everything beautifully. Look how pretty that is. I'm going to fix the other one. Okay. Whew. That graph just got a lot more fun. Am I right, folks? No? Okay. All right, what next? Yeah. So we got the factors on the top, and those tell us the x-intercepts, which are 4 and negative 2. All right. So negative 2 and 4. Okay. So we have to find the domain, right? But that's not really going to help us draw our graph, but it's still good to find. So the domain, I did this in 3rd period yesterday, but I didn't with you guys. I'm sorry. Here's my next color. It's brown. And the brown uses both the whole and the vertical asymptote to help you find the domain, which is why I'm underlining it. So the domain comes from both of these. We have to exclude which values? 2 and 0. So the reason we don't exclude the -2 is because it's not in parentheses as like a plus. X plus 2 would give you -2. Whenever you have a coefficient of x in the front, we just ignore it. This meant reflect over the x-axis and vertical compression of 1/2. That's technically what it meant. So we're going to say skip 2, skip 0. And then what do we do to write the domain? -∞, 0, so we make sure we do the smaller number first. 0 to 2, 2 to infinity. Okay, and for the domain, there's nothing to draw. Okay, so at this point, we grab a calculator. If you guys haven't grabbed one yet, feel free to go over there and grab one. Yeah. Isn't it nice that I have so many staplers in here? Why aren't you guys just walking around with big smiles on your face because you love this so much? Nobody?
I got in trouble at my job for not smiling.
Yeah, I mean, if you're a grader, that makes sense. All right, so to type this in so that we don't have fractions, we cannot plug this in as a fraction because then the graph will give us fractions. Those are harder to graph. So what I'm going to do is I'm going to put the top in parentheses and I'm going to put the bottom in parentheses. So I have parentheses x to the third minus 2x to the second minus 8x, and then I'm going to end parentheses. So that's me telling my calculator this stuff all goes on the top. And then I'm going to hit divide by, and I'm going to do parentheses again. So -2x squared plus 4x. I made sure that I have parentheses around all of that. All right, we good with typing it in? So we hit graph. And then we have a couple different ways of looking to see what the different points are. You can do, if you hit the trace button, then it will put your cursor on the curve and you can just kind of trace back and forth and find some points to write down. Some students like to do that. I often like to do second trace value. That's where you can plug in whatever x value you want. And then you could plug in like x is -2, -5, -4. I can just start plugging in the x values and let it spit out the answers that I want. Whichever way you do it is fine. I just want to show you, so you could look at the table, you can do second graph and look at the table and do it that way. So since we typed it in the way that we typed it, it's giving us decimals. If you had typed it in like this, right, that looks nicer because it looks exactly like what's on our page. But if you look at the graph, then it's going to give you all fractions, and those are a lot harder to graph. Okay, so the reason, and if I do value and I start plugging in numbers, it's going to give me fractions to graph instead of decimals. So one of the reasons I had you type it in like this is because it gives you values that are easier for you to graph. Okay, so go ahead and pick some points to draw on there. I'm going to plug in some whole numbers. So I know what happens at x equals 0. That's the whole. I know what happens at x equals -2, so I'm concerned about some of the other stuff there. So I'm going to plug in like -3.7, -5 is 1.9, -7. Miss Rice, how many points do you need? I don't know, a lot. Enough to draw it. Okay, so I just plugged in a bunch of different points, and now I can go ahead and draw this curve, and I'm making sure it goes It goes through the X-intercept that I drew. It's going to go through the hole that I drew. I'll try to make it look nice, but that's kind of hard sometimes. Okay, look. What a pretty little curve we have. Did you guys get that? Does it look nice?
Not as nice as yours.
Oh, you get an A, sir.
I need it.
All right, and then I'm going to plug in some more values on the right so I can see what's happening there. So I'll plug in like 3. 3 is 2.5. You can also kind of check and make sure your asymptotes are right and make sure the hole's right. So if I try to plug in 0, I get no answer. So that tells me I was right to notice that something funky happened there. So that's where the hole is. And then if I plug in 2, I also don't get a value, and that's because there's a vertical asymptote there. So it's nice because the calculator can help you kind of check your work. 5 is negative 1. Yeah. Oh, geez. I just missed that point. I really missed it. They're right up here. Mm-hmm. Okay. So on here, we're going to practice today just finding that end behavior and make sure we can get it and write it correctly. So I'm going to say as x goes to the left and as x goes to the right, so always check the left side of the graph and the right side of the graph. So as we look at the left side, the x is going left. The y value of the graph is doing what? It's going up, positive infinity. As x goes to the right, the y value of the graph is going down, so it's going to negative infinity. Okay, so there's our end behavior. All right. How are your brains with that stuff? Okay? Okay? Yeah, we're going to do one more. All right. Here's the next one. All right, for this one, we're going to do x squared plus 3x plus 2 over negative 4x minus 12. So, what do you guys want to find first? The y-intercept? Okay, so the y-intercept is okay, so 0, negative 1 over 6. And if I graph that just right underneath the x-axis there. Okay. What do we want to find next? So if we look here, what do you guys see? There is none, because the degree of the top is a 2, the degree of the bottom is a 1. So what does that mean? Oblique, and we have to do some long division. So we're going to do x squared minus 3x plus 2. It was plus. My marker went over it. Sorry. X squared plus 3x plus 2, thank you, divided by negative 4x minus 12. Okay. So if we look at this, what do we have? Negative 1/4 x. So negative 1/4 x multiplied by negative 4x is x squared. Negative 1/4 x times negative 12 is 3x. We draw the line. We change the signs. We get 0 and 0. I swear I didn't do this on purpose. It's the same oblique asymptote as the last one. It's very strange. Oh, it's not. It's close. It's similar to the last one, but it's not the same. Okay, so next we're going to say negative 4x times what is 0? 0. So we're going to put plus 0. Okay. So our oblique asymptote is y equals negative 1/4 x plus 0. And we can go ahead and graph that. So y-intercept of 0, we're going to go down 1 to the right 4, down 1 to the right 4, up 1, left 4, up 1, left 4. And we're going to make that a dotted line. I wish I had a ruler over here. We'll see how I do. No, that's okay. That's alright. Okay, what do we want to do next? Factor. So on the top, x squared plus 3x plus 2 is what? X squared plus 3x plus 2. X plus 2, x plus 1. The bottom is negative 4x minus 12. Take out a negative 4. And x plus 3 is what you have left. Okay. Are there any holes in the graph? Nope. None, because nothing canceled. Alright, what else do you guys want to find? So the vertical asymptote is x equals negative 3. Make sure you do get that x equals in there because I would mark you down if you didn't. Why is having the x equals important? Anybody know? You're writing the equation of a vertical line. So you're not saying that there's one x value that is a vertical asymptote. You're saying that's a vertical line that makes an asymptote, and the way that we write the equation of a vertical line is we say x equals the number that it's at. So since we're writing an equation, we got to have x equals negative 3. It'd be kind of like you writing your oblique asymptote and just saying my oblique asymptote is negative 1/4 x plus 0. That's a little strange. It makes more sense to say y equals mx plus b than just say mx plus b. Okay, same thing here. So we say x equals negative 3. All right, what do we find next? We can do the x-intercepts. We're also going to do the domain in a second. So x-intercepts would be negative 2 and negative 1. I can graph those, -2 and -1. It's kind of interesting. Huh? All right, and then last, we'll make sure that we have the domain. So this is the domain. Why am I not looking at the -4 to find the domain? There's no x with it. Since there's no x with it, it doesn't tell us much. All right, so the domain is we have to skip what x value? -3, so we're going to write -infinity to -3. -3 to infinity. Okay, so I'm going to go ahead and type this on my calculator. I'm going to do top in parentheses divided by the bottom in parentheses. I'm going to hit graph. Okay, so I want to, what method did you guys prefer to find the values? Typing in the values, trace? Okay, so you can hit the trace button, and then you just have to find where your cursor is, then you can write down some points. Or we can do second trace, and we can plug in the values that we want to find. Or if you just want to hit the graph, second graph, then you can look at the table, find some values that way. So I want to make sure, I don't have any points over here, I want to make sure to get some points over there. If you want to see what happens, because right here, I can see what happens at -4, but I'm not sure what happens right here. I understand the way asymptotes work, where the curve gets really close to it, and I can see on the screen that it curls up. But if you want to get some better points, you can even plug in decimals, like -3.5 would get you a little bit better on this one. -3.25. All right, and then over here we have a lot of points already. I don't know that we really need a lot more, but I'll go ahead and do like -2.5. Now, right here, I did a bad job drawing this because we know that if it went through this x-intercept, it wouldn't go straight across, it would bump up a little bit. All right, so our graph looks something like that. All right, how are we doing with the drawing? Not finding it okay? What part of it do we not like? Finding extra points or drawing this, finding the extra points? What method are you using right now to find the extra points? Trace? Okay. So trace sometimes might not feel as great because you have like decimals for the x and for the y, so you might try doing second trace and plugging a number in for the value, and then at least your x coordinate could be a whole number. Might be a little bit easier for you to graph. So if you do number 1, then you can just start typing in the x values that you want. So you could type in like -4. You don't even have to go back to the menu. You can just keep typing whatever you want in there. And it will just give them to you. And then the nice thing is the x value is a nice whole number, and the y value is the decimal. It makes it a little easier to graph, I think. All right. So let's go ahead and figure out the end behavior for this. So as x goes to the left and as x goes to the right, All right, so as we look at the left of our graph, here's our curve, and here's where it's going to the left. So the x value is going to the left. What is the y value doing? Is it going up or down? It's going up, just not very quick, right? I can see it slanted up a little bit. So it's going to go up, so I'm going to say y goes up. Y goes to positive infinity. For this one, as x goes to the right, y goes down, negative infinity. Okay.